Hello everyone, I'm Hassan Salibi, a master student in computer science at VUB University. This knowledge clip is about concurrent task tree technique, CTT, which is used in task modeling. In this video, I will explain the CTT features, the task categories, the temporal relationships between tasks, the rules to be followed when using CTT, and some special cases which we may face them while using this technique. Before going through this technique, I will talk about the task modeling and why we use it. Task model is a way to describe the logical activities that have to be carried out in order to reach the user's goal. It is useful when designing and developing interactive systems. We use task modeling to improve understanding of how tasks should be performed, to predict how long users will take to learn a task and to perform a task. In other words, to measure the usability of the system. To support interdisciplinary decisions. To model how to support tasks in supporting systems. There are different techniques to model tasks. CTT one of them. It is mostly used in HCI for UI design of interactive applications. The basic idea of using CTT is decomposing tasks into subtasks. As we see here, task 1 is decomposed into task 2 and task 3. The advantages of using CTT are the following: expressive graphical notations for task modeling with precise semantics, high-level descriptions that can also be understood by people without programming background, allows to indicate how to use information in the task model, provide input for the user interface design, availability of tools to create models, analyze them, and use them for user interface design. There are several principles of CTT we should consider. Focus on the activities, avoiding low-level implementation, based on hierarchical decomposition of activities. Allow to express temporal relationships between activities. Distinguishes between different categories of activities. There are four main task categories. The first one is user tasks, which performed by the user. We call this cognitive activities, such as making a decision or answering the phone. The second one is application task, which completely performed by the application or the system, such as checking a login username and the password. The third one is an interaction task, which performed by the user while interacting with the system by some interaction techniques, such as editing a picture or filling a form. The fourth one is abstract task, which requires complex activities and has to be decomposed into subtasks, such as a user session with the system. As we see here, we decompose task 1 to task 2 and task 3 by tree structure. Task 1 is in the top level, which is the most abstract level. Task 2 and task 3 are in the bottom level, which is the most detailed level. We can read this. In order to do task 1, we need to do task 2 or task 3. Now I will start to explain the temporal relationships between tasks. The first one is the order independence relationship. With this relationship, the tasks can be performed in any order, but when one starts, then it has to finish before the other one can start. For example, when people install new software, they can start by either registering or implementing the installation, but if they start one task, they have to finish it before moving to other one. Another type of relationships is the choice between two tasks or more, but once one has started, the other one is no longer enabled. For example, when accessing a website, it is possible either to browse or to access some detailed information. The tasks with interleaving relationship can be performed in any order or at the same time, including the possibility of starting a task before the other one has been completed. For example, printing and editing a file. Tasks with interleaving with information exchange relationship can exchange information while performed as interleaving tasks. For example, editing a document and reading the document at the same time. In parallelism relationships, tasks are performed in true parallelism. For example, retrieve email and send email. When there is a deactivation relationship between two tasks, the first one is stopped by the activation of the second one. For example, a user can input data in a form until the form is sent. That means sending the form will disable the input of data. The enabling relationship specifies that the second task cannot begin until the first task is performed and finished. For example, user cannot formulate a query until he has logged in. Enabling with information exchange relationship. It's like enabling, but also specifies that information produced in the first task is used as input for the second one. For example, the system looks for a document only after the user specifies its ID, and the results will depend on the ID specified. Suspend-resume relationship. In this relationship, the first task can be interrupted by the second one. When the second terminates, then the first one will be reactivated from the state reached before. For example, editing a document can be interrupted by using the help. While help is performed, it is not possible to edit. Editing is resumed if the user finishes using the help. Iteration. The task is performed iteratively. When it terminates, its execution is started again from the beginning. For example, search facility. After finish a search, a new search can be performed. Optional. The task will be an optional task. For example, entering a GSM number is an optional task. Recursion. In the decomposition of the task is used again. For example, a user can browse or search for products. Browsing is done by selecting a subcategory. After that, the user can again browse or search. Now we will start with the rules which should be followed when we use CTT. The first rule is, if the children have the same type, the parent also should have the type of the children. In this example we can see the children have the same type of interaction task, so the parent also have the same type. The second rule is, if the children are different types of tasks, so the parent must be an abstract task. As we see here in this example, the first children is an application task, and the second one is an interaction task, so the parent must be an abstract task. The third rule is, same task can appear in different subtrees. The fourth rule is, at each level, temporal direction of executing the tasks is from left to right. Priority order rules illustrate in which order the task will be performed. So the choice relationship has higher priority than interleaving and order-independent relationships. The order-independent relationship has higher priority than disabling. Disabling relationship has higher priority than suspend and resume. Suspend and resume has higher priority than enabling and enabling with information exchange. Now we will start to illustrate the special cases in relationships between parent task and its subtasks. We can see in the first example, the parent task has an iteration, and the subtasks have interleaving relationship between them. So in this case, the interleaving will be repeated. In the second example, the iteration exists in the subtasks, and there is an interleaving relationship between the subtasks too. In this case, there will be continuous interleaving. The second special case is iteration with the choice. As we see in the first example, there is an iteration in the parent task, and there is a choice relationship between subtasks. So in this case, there will be an iterative choice. In the second example, the iteration exists in the subtasks, and there is a choice relationship between them too. In this case, the iteration will be done for the task which is chosen. If we have an iteration in subtask like this example, when this task is over, it will repeat itself, and the iteration will never stop. To solve this problem, we will add interaction task to disable the iteration in the subtask. The final special case, and it's for choice tasks, that we have make sure that tasks the user has to choose from have an interaction task to start with. Otherwise, the user will not be able to make the choice in the user interface. Thank you for watching this video. I hope you enjoy it.